Identify the mass and molar mass of the solute. The problem states that the solution contains 34 grams of strontium iodide, Sre2, which has a molar mass of 341 grams per mole. Calculate the moles of solute. Use the mass-to-mole conversion formula to find the moles of Sre2 in the sample. Moles of Sre2 is equal to 34 grams over 341 grams per mole, approximately 0.10 moles. Determine the molarity of the Sre2 solution. Molarity, M, is defined as the moles of solute per liter of solution. Since the total volume of the solution is 1.0 liters, molarity of Sre2 is equal to 0.10 moles over 1.0 liters equals 0.10 molar. Analyze the dissociation of strontium iodide. Strontium iodide is a soluble ionic salt and a strong electrolyte. In an aqueous solution, it dissociates completely into its constituent ions. Sre2 gives senior to the power 2 plus 2 I to the power negative. This stoichiometric relationship shows that for every 1 mole of dissolved Sre2, there are 2 moles of aqueous iodide, I to the power negative, ions released into the solution. Calculate the final molarity of I to the power negative ions. Multiply the molarity of the parent salt solution by the stoichiometric factor of 2. Molarity of I to the power negative equals 2 times 0.10 molar equals 0.20 molar. This confirms that the correct answer is option D. The correct answer is option D, 0.20 molar.